Hey guys, we've got some bonus content for y'all this week. So this Tuesday's workshop on build pipelines was all about the process your code goes through from when you complete a new feature to when you push it onto GitHub to the review process and CI/CD, and basically just the whole path your code goes through on the way to being deployed. It's basically kind of an introduction to some of the ideas in the DevOps space, and one of those things we talked about was continuous integration, which is basically automated checks that you can run on your code to make sure everything's right. It's automated testing. Now, we mainly talked about it from the viewpoint of how to use CI tools that will already be on the code base when you get to your internships. So whenever you run a pull request, how do you check to see if the CI build passed? Were there any issues? If something failed, how can you go and troubleshoot it and check the logs to see what went wrong? That kind of thing. Because most of y'all aren't going to have to set up a CI pipeline yourselves during your internship, but it's actually surprisingly easy to set up a very simple CI system. And it is a pretty good idea to do that for one of your own projects because one, this is a very relevant tool that is used every day in the industry. And two, very, very few college students know how to do this. So it will really make you stand out and prepare you really well for your internship. Now, there's a few different providers. We're going to be using GitHub Actions for this example because most of y'all have used GitHub before, so you can integrate this into your existing projects pretty well. And this is what our demo looks like. So I have a very small JavaScript project. The language you use doesn't really matter. I'm just using JavaScript because it's easy for me to set up. And I have a single code file. It's got a function that takes two numbers and adds them. And I have a single unit test for that function. So first things first, if you're doing continuous integration, you need some kind of check, right? The whole idea is it's automated testing. So if you don't have any unit tests, that would probably be the easiest place to start before going and adding CI. So if you haven't written any tests, you'll probably want to do that first. There are other things you can do. You can do some like linting checks if you haven't started on your tests yet. So that would be a simple way to add CI. But I'm just going to use a unit test as an example here because everyone understands it. Most of y'all understand what a unit test is. That being said, any kind of check you want that you can put in a script can be something that you can check in continuous integration. So this test is pretty self-explanatory. It just checks that my function that adds two numbers returns a correct result. And if I come here and run npm run tests in my terminal, it will run the test and tell me that I know how to add numbers very slowly. But yeah, I need to make sure you have some kind of command to run the test. Like I said, it'll be different depending on your programming language, but make sure you find out what that command is. For JavaScript, it's going to be npm run test. And there will be some additional setup in the package JSON. This isn't a JavaScript tutorial. We have those things. We've got some code. We've got a test. How do we do our continuous integration? Well, first, for GitHub Actions specifically, this will be different if you're using another provider. We're going to create a folder at the root of our project called .github. This is a folder, not a file. And then we'll create another folder under that called workflows. So GitHub/workflows. Now, the way GitHub Actions works is it uses something called a workflow, which is basically an ordered list of scripts that GitHub will run whenever a certain event happens. Now, what do I mean by event? One example of an event is whenever you push some new code up to GitHub to a certain branch. So let's say you just complete a new feature and you push that code up to GitHub. GitHub will be listening to that. And whenever the new code is up there, GitHub will say, oh, you just pushed some new code up to this feature. I'm going to run this workflow that you have in this folder. So let's go ahead and create the workflow. we're going to create a file called test.workflow.yaml. So test is the name of the file. All of your workflows need to end in .workflow.yaml. And a YAML file is kind of like JSON if you've used it before, but it's indent sensitive instead of it doesn't use braces, it's indented, kind of like Python, so be careful, it's easy to make a mistake there. And I'm going to cheat a little bit and copy and paste the code that's going to go in here, but of course we're still going to go through this line by line. So this is the workflow that is going to enable our continuous integration. What does all this mean? The very first line here, on push. So on is basically saying what event is going to cause this workflow to run. And like we just said in this example, we want this workflow to run anytime we push code to a new branch on our GitHub repo. So by saying on push, it's going to run it anytime that happens. You can also add a lot of extra options here. So if I want it to run on a certain branch, I can do on push branches. And let's say I only wanted this to run when I push code to my main branch, I would write it like this. But for now, to keep the example simple, I'm just going to have this run anytime we push to any branch on our GitHub repo. All right, and now jobs here. Jobs are basically going to be the workflows that we want. It's basically going to be the list of scripts that we want to run. So this one is going to be called test. And what's this thing here runs on? So if you guys haven't worked with containers before, kind of like a container as in a Docker container, GitHub runs all of your workflows in a container. And a container is basically a lightweight virtual machine where you can run pretty much any kind of code you want, and it bundles in any dependencies you have. So that way you have everything you need to run your program with you, and it's easy to run anywhere. So for example, in this container, we're going to install JavaScript so I can run my JavaScript tests, install the necessary JavaScript libraries, and then actually run my test script. So that's what a container does. And this runs on command right here is basically just saying what operating system is your container going to use. And Ubuntu is a very popular version of Linux. So this is just basically saying, hey, run this on Linux. Now, steps is going to be a list of all the individual scripts basically that we are going to run in this workflow. So first, we can see that each step has a name. Make sure you put a name for each step, so that way if you need to look through the logs later, you can read through it easily. Now, the first step here is going to be checkout repo. Now, remember, when you load a container, it's going to be completely blank. So before we can run the test, we actually have to download all of our code into the container. So we're going to need to run a script that does that. But, you know, you might be thinking, well, I want to, you know, write a script myself to basically download the code from GitHub and clone it into a new Git repo in a container? No, you don't. And that's going to bring us to this uses keyword right here. What uses does is it allows us to reuse existing workflows in our own. And this is really good because we can combine workflows and not have to do as much work. So this right here is called action/checkout. And this checks out another GitHub repository and downloads that code into the container that you're running your workflow on. So basically, all this step does right here is it downloads the code we have in our repository, so that way we have the code we need to run our tests, right? And you can actually look at this action on GitHub. So if you go to github.com/actions/checkout, you can see everything for it right here, and it has usage instructions. In general, the syntax for using the other workflow on GitHub is going to be the name of the GitHub profile. So this comes from the actions page on GitHub. Like GitHub literally has a profile called actions. This is an account. If there was a workflow from SSD that you wanted to reuse for any reason, you would do UFSSD because that's their profile name, and then the name of the repo that had the workflow. So /checkout is the name of this workflow's repo. And if there's a file called action.yaml at the root of the repo, that's all you need, and that is how it works for any of the default GitHub workflows. If you want to use a workflow that's a part of someone else's project but they don't have the action.yaml at the root, then you'll need to go into the GitHub /workflows folder that we have, and then basically get the full path to that. So I'm going to just make something here. So if I call it fake.workflow.yaml, and let's say I wanted to have an extra step here that said fake workflow. I would do uses UFSSD and then the name of the repo and then the full path to that folder. So it'd be .github/workflows. Got it. So that would be the full path. And if you're in this using another workflow from the same repo, because UFSSD/CI demo is this repo, you can omit the name of the repo. And so, yeah, that is very important if you want to reuse your own workflows. Now, if that was a bit much, just feel free to kind of come back to this later. If you're using any of the default GitHub actions, it's just going to be action / the name of the action. So again, let's review where we're at so far. Runs on, we're going to run this on Linux, and the first step is going to be checkout repo, which just downloads all the code in our repository so we can get the tests to run. Next step is going to be name setup node, and this is going to use another one of GitHub's actions called setup node. And what we're doing here is basically setting up our JavaScript runtime. And I'm using Node.js, so the container has to install Node.js to run any code in it. Now, this will be different depending on what language you're using. So if you are writing Python, for example, you would use a workflow that sets up Python in a container. You're also able to specify the version that you want here, which is very important. Make sure you're using a version that matches your code. The next step here is going to be install dependencies. So this is going to install any external libraries that you might need to run your tests. I'm using a testing library called Jest, so I need to make sure I have that installed to be able to use it. So run whatever the command is to install your libraries for your language. npm CI would be it for JavaScript. If you're using Python, it might be pip install or whatever it is for your language. And notice how this time the command is run. So run is what we'll use when we're running a script from within our own code base, right? So this is a script from within our own code base. And then finally, what we actually wanted to do, we've got everything set up. Now we can actually run the test. And we're going to run whatever our test command is. And for me, it's npm run test. Again, will be different for you depending on what programming language you're using. So that's a basic workflow file. You tell GitHub when you want the workflow to run, what kind of container you want it to run in, and what steps you want it to take. What other workflows and scripts do you want to run in order? So now let's go ahead and save that. And let me get rid of the example that I had here. So cool, we've created this workflow file, But that's not all that we have to do. So to run this in GitHub, we need to get it up to GitHub. So let's go ahead and commit that. So git add, git commit, add CI workflow with unit test. And we've gone ahead and committed that, and I'm going to go ahead and push that up to my GitHub repo. So that'll take a second, and it's gone up. So now if we come back to our repo here and hit refresh, we'll see now that we've got the GitHub workflows folder, and we can see this here. Now, if I go ahead and come to, let's see, back to the root of the repo here and click the actions button right here, I have a list of all the actions that are in my project, and we can see a list of all of our workflows here. As we can see, everything that we put in that workflows folder with the name, with the workflow naming convention .workflow.yaml is showing up on the left side here automatically. I can also see every time these workflows ran in the past. These were some test runs for this demo that I did earlier. And this fail here, and we can also see some of the status here. So it's actually telling me I've got an error in my YAML file. Oh, looks like I had a tab that I'm not supposed to. Like I said, if you've never worked with YAML or anything like Python before, be careful because it is indent sensitive. So let me just go ahead and fix that real quick. And push that back up to master. All right, sorry for wasting about 30 seconds of your guys' lives. But now, as we can see, when we come back to the branch, we have a yellow dot that says pending. This basically is the workflow running. Now, anytime we push some new code up to a branch, it's going to run the workflow and let us know what the status of it is. And as we can see, all the checks just passed. So if I refresh this now, I'm going to have a green check mark here that says my continuous integration passed, and nothing is broken with my code according to the workflow that we just wrote. Now, if I come here, we can look at the details for here. So we have each individual step. So if we come back and look at the workflow file, we can see our steps were, scroll too far. Our steps were checkout repo, setup node, install dependencies, run tests, and all of those are right here. So checkout repo, setup node, install dependencies, run tests. And if we click and expand each of these, we can see all of the logs here that show the output. We showed this in Tuesday's workshop. This is great to look at when things go wrong. But there's one more thing we want to do to get this really working like a professional repo, and that's blocking people from merging new code and if it fails the continuous integration. So you do that through the GitHub settings. So come to the repository settings right here, come to branches, and we're gonna add a branch protection rule. So first things first, you have to tell it what branch you want this to apply to. You can either type in just the name of a branch or use a regular expression. I'm just going to use the branch name master. So there's a few things you can do here. One is to require a pull request before merging. So I'll go ahead and do that. I'm not going to require approval since it's just me. But again, in a real code base, you will almost always need to get approval from another developer before you can merge. And this one right here, require status checks to pass before merging. So this is the one that you will want to click to basically block anyone from merging in code that fails continuous integration. So now we've done that, we can hit create, and that rule now applies to this branch. So let's go ahead and test it out to see if our CI system is working. So what I'm going to do is come back to my code here, and I'm going to add some code with a failing unit test on purpose. And what should happen is it should cause that unit test to fail into continuous integration and not allow me to merge it when I open a pull request. So first, let me go ahead and create a new branch so I have something to merge into. So let's call this branch add multiplication demo, or let's do subtraction instead. Add subtraction demo. So I'm going to create a new file called new code file called subtract2numbers.js. And you can probably guess what this function is going to do. It's going to take two numbers and return a difference between them. But I'm going to intentionally add an error here. And let me put a comment there so anyone who looks at this repo doesn't think I suck at math. And I'm just going to go ahead and copy this. There we go. So we've got our broken function now, and let's go ahead and write a unit test that is not broken for this. So the unit test here should rightfully see that something is wrong. So subtract two numbers test. Let me go ahead and replace everything here. So let's replace add with subtract. Did it not? Oh, I had a period there. So my find and replace didn't work. There we go. So now let's go ahead and pick two numbers. So for my test, I want to say 10 minus 7 should equal 3. So now I'll go ahead and write in my unit test. If I run the function subtract two numbers, 10 and 7, I should expect the result to be 3. So now we know that because we put an intentional bug in our function, the unit test is going to fail if we run it. And so if I run npm test real quick, just to show that this should fail locally. Also, just for the record, it typically is good practice to like actually run your unit tests before you open a pull request, because it's annoying if you have to basically pull it down and then push it back up to GitHub again, especially if you already asked your coworker to review your pull request. And as we can see, this unit test just failed, right? But let's pretend we're bad developers for a second, and we're going to try to push this code anyway. So I'm going to do git add, git commit, add broken subtraction function. And now that's been added. And I'm going to go ahead and push this to a new branch, not master, push this to a new branch on our remote GitHub repo. So git push origin. This is going to create a new branch called add subtraction demo. And when I come back to GitHub now, we can see we've got a new branch. So let's go to compare it and pull request. And is it going to let me merge this pull request in? So let me add a description. Added broken code to cause failing unit tests to demonstrate continuous integration. Let's create the pull request. And oh, all checks have failed. So it's not letting us merge, which means we have successfully set up a continuous integration pipeline. And this is just how it would work in a real company. Now, granted, it will be a bit more complex. There are a whole bunch more scripts that you could add. You could also do things like a continuous deployment, which is very similar to this process, except instead of adding a testing script, you would run a deployment script that would call AWS or whatever cloud provider you use. And just like in a real company, you can hit details here, go through all your logs, see what went wrong, and that is working as intended. So thank you guys for tuning in. Hopefully this will help you guys make your code bases look a little bit more professional and also help you really understand what's going on when you see this in a real company. I'll see you guys at the next SSD meeting.